Welcome. Let's do some practice problems with limits. On the left-hand side, we have the graph of some function. Let's call this function f of x. And what we want to do, we want to find the evaluation of the following 5 limits. Let's take a look at the first one. Here we're interested on finding the limit as x approaches the value of -1. Let's identify it in our graph. That is in here. But notice that there's a little negative on the value of -1. That is giving us an indication of direction. So here, we want to identify what value are we approaching as we get closer to x equals -1 from the left-hand side. So let's use the graph to identify that value. As we start getting closer to -1 from the left, if we follow the curvature of this function, notice that the y value that we are approaching is y being equivalent to 2. Now let's take a look at the second example. Here we're saying we want to identify the value that we are approaching as we start getting closer to the x value of -1. Let's identify that. So we have it here. But notice that there's a little plus on top of the -1. That is giving us direction. That plus is telling us that we want to consider the direction from the right-hand side. So let's use our graph. So if we start approaching the value of x equals -1 from the right, and we follow the curvature of this function, notice that the y value that we are approaching is y equals to +2. So we have found our second limit. Now let's take a look at our third example. What we want to find is the value that we are approaching as x is getting closer to -1. But notice that on top of -1, there's neither a plus or neither a minus. So we want to consider both directions. When we approach the value of -1 from the left, notice that we are approaching the y value of 2, which is exactly what we found in our first limit. And as we approach the x value of -1 from the right, notice that we're also approaching the y value of 2, which is what we found here in our second limit. And here, notice that the left and the right are both agreeing on the same destination. Then we can claim that the limit exists at the value that they're approaching, which in this case, it is a y value of 2. Now let's take a look at the next example. In here, we want to consider the limit as x is approaching +4. Let's identify that in our graph, which we have it here. Notice that there is neither a plus or a minus on top of the value. We have to consider both directions, the direction of the left and the direction on the right. Let's start by looking at the direction from the left. If we get close to the value of x equals 4 from the left, and we follow the curvature of this function, notice that we are getting close to the y value of -3. And if we approach the value of x equals 4 from the right, and we follow the curvature of this function, notice that we are getting close to the y value of -2. So notice that the destination from the left is not the same as the destination from the right. Those destinations do not agree with each other. Therefore, the limit at this specific point of x equals 4 does not exist. For a limit to exist, we have to approach the same value from the direction of the left and the direction of the right. Now let's take a look at our last example, example 5. We are interested in finding the limit as x is approaching the x value of -4. Let's start by identifying that location, which is here. Notice that there is no plus or minus on top of the destination of -4, so we need to consider both directions, the left and the right. Let's take a look at one at a time. Let's consider the scenario when we approach the x value of -4 from the left. If we follow the curvature of this function, As we get close to the x value of -4 from the left, notice that we are getting close to the y value of +3. And if we approach the x value of -4 from the right, if we follow the curvature of this function, as we get close to -4 from the right, notice that we are approaching the y value of 4. The destination from the left and the destination on the right are different. They do not agree with each other. Then we're going to claim that the limit as x is approaching -4, it does not exist. For a limit to exist, we have to agree on both destinations, the left and the right. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.